Hello everybody. So today's session is on copy of list object. So my name is Subhrajit, assistant professor in Nursery Engineering College. I welcome all you to this session. Today's session is a copy of list object. In the last video, I had discussed about the nested list, right? Nested list concept we covered in the last video. Now this is the today class session, copy of list object. What is the meaning? Everybody know, you know, I know, everybody know what is the meaning of copy. Right? Creating the duplicates data. Creating the duplicate data is nothing but copy. Right? So we are doing practically every times copy of any folder in the computer, copy of any file, right? We are creating the copy. The same thing here also, but by using Python, we can do two types of copy. Two types of copy is possible in the Pythons, right? Two types of copy is possible. Copy is allowed here. Allowed. What is the one? First one is called shallow copy. Shallow copy. And second one is called deep copy. Okay, what is shallow copy and what is deep copy? I will tell. Okay, shallow copy and deep copy. In Python, there is a model. Okay, in the Python, so to implement these two types of copy, we need to use one model, one library. Okay, here we need to use one module or library named as copy named as copy module or copy library. You have to use to implement this one. Actually, shallow copy is not required any library or model, but deep copy is required. Shallow copy without library also we can use the concept of shallow copy without using the copy model. Whereas in the deep copy, we have to use the copy model. Sir, what is the difference here, shallow copy and deep copy? I will tell you. Observe here through diagrammatically examples. I will tell you. Suppose I have a list. Suppose L equal to, suppose L1 equal to, right? L1 equal to having eliminated list. Suppose 10, 20, and another element is there 30, 40 is there. L1 contains how many elements? Sorry, L1 contains two elements only. This is first element and this is second element. And here the first element itself is a list, and second element also it is a list. So nested list, right? L1 is a list. Again, inside the L1, two lists are present. So this is the outer list, and inside the list it is called inner list. So list inside list is there, nested list, right? So L1 contains two elements. Again, the first element of L1 contains again two elements, and second element of L1 contains again two elements, right? So indexing, you know very well how to do the indexing. This is 0, this is 1. And for this nested list, first one, this is 0, this is 1, and this is 0, this is 1. So what happened in the memory if I'll write this one? If I'll write this one, what will be happening in the memory? In the memory, L1 object will be created. Okay, L1 object will be created. This L1 contains two elements. Again, the first element of L1 contains two elements, and the second element of L1 also contains two elements, right? So here This is two element, and here also two element. Two elements contain here. This is the diagramical representation of the nested list for the current example. So this is my list name is L1, L1, and this one is L1 of 0, and this is L1 of 1. L1 of 0 means this 10, 20, here 10, 20, and here 30 and 40. So what happened in the computer memory? In the computer memory, for L1, one object will be created. L1. For L1 of 0, one object will be created. For L1 of 1 also, one object will be created. Right? And here L1 of 0 contain how many elements? Are two elements. So for L1 of 0, two object will be created. And L1 of 1 also contain two element. So for that two element also, that is 30 and 40. For 31 object, for 41 object will be created in the memory. Let the here this is L1, this is L1 of 0, this is L1 of 1, and this is the object for 10, 20, 30 and 40. Right. Now for every object there is a address number. Suppose this is 1001, 1002, 1003, 1004. This is 5. Suppose this is 6 address number I am giving randomly, but actually it is a big number. If I print ID of 10, ID of 20, ID of 30, it is a big number will come, but in short form I am writing like this way. Then this 10 is what? L1 of 0, L1 of 0 first element. Okay, L1 of 0 first element is the 10. L1 of 0 second element is the 20. So this 10, 100 address will be stored here. Where? Here 1001. Here 1002, 1003 and 1004 will be stored here. So corresponding value at 1001 is 10. So this is the first element of L1 of 0, and 20 is the second element. Here address location will be stored. In the same way, in the L1, which address will be stored? In the L1, 1005 is the first element address, and 1006 is the second element address will be stored here. Right? And for L1, what is the address? L1 address is 1007 address, right? In L1 address. Now, suppose I will do shallow copy. This is the internal things happen if I declare L1 equal to this much. L1 equal to this much if I declare, then internally in the memory will be allocated like this. Now, what I'm doing, sir, I'm doing the shallow copy. Shallow copy. How to write the shallow copy? Here I told a copy module is not required. Directly I can write. Suppose I want to copy to another list, name is L2 equal to L1 dot copy. If I'll write like this, then totally the L1 will be copied to L2, but not totally. Observe here. If I'll do like this, then what will be happen? What will be happen, sir? L2 object will be created. L2 variable will be created here. Right? L2. This is L2. L2 will be created. So it contains how many elements? L2. Here L1 same as L1, two elements. Two elements will be contains. Right? Here for L2, for L2, one more object will be created. L2, one more object will be created. Now see, here focus, very important this one. For L2, one more object is created, and here L2 store. L2 is stored. Now L2 contains two elements. This is the first element and this is the second element. Okay, so here what will be happen? L1 of 0 address will be stored here. L1 of 0 address will be stored here, 1005. Okay, for here L1 of 0, one address is consumed, but while I will copy the total L1 value by using the shallow copy to L2, then this element address will be copied to the new object L2. Okay, the element address of L1, that address is 1005 and 1006, that will be copied to the new object or new list L2. Again, this 105 having 1005 having two elements, 1006 having also two elements, right? So here again two elements here, and here also two elements, right? Now what will be happen here, sir? Here same address of 1001, here 1001 will be copied, and here 1002 will be copied, 10003 will be copied, and 1004 will be copied. So in a shallow copy, by writing this shallow copy concept will be implemented. In the shallow copy, every element address is copied, but unfortunately the main list here name is L2, that 107 will not copy here. It will not copy here. Rather, a new object will be created in the location, suppose 1008. Okay, so the outer list of this L1 outer list, it will be not copied to L2, but whereas the address of every inner list and every individual elements will copy to the new list L2. This is called shallow copy. So what will be happen if I do like this? If I do like this, suppose in the next attempt I am changing 1001 value 10 to 100. Okay, 10 to 100 in this location, then what will be happen? 1001 also here, 1001 also here, same address location number. That means, so this 10 will be replaced here. It will come like this, right? It will come here also 10, 20, 30. I copied this one, so exactly same value will be copied here, but this address location will be changed. Okay, this address will be not copied, but elements will be copied here. Now suppose what I am doing, I am changing the 1001 location value 10 to 100, then what will be happen? Automatically here also it will be changed to 10 to 100, and here also it will be changed to 10 to 100. Okay, suppose I am changing the element in L2, suppose this is 32, I am changing the 300. Okay, I am changing the 300. That means 30 means 1003. So 1003 become 300. So since 1003 is pointing to L2 as well as L1, so here also automatically it will change to 300. Right? Because why sir these things is happening? Because see, all the inner list, all the elements having same address location, not different address locations, right? The same address location. That's why it is changing. Here also 1005, 1006, here 1005, 1006, here also 1005, 1006. So whatever I am changing in the inner list in the L1, that will be reflected in L2, and whatever I am changing the inner list of L2, that will be reflected in L1. Right? This is nothing but called shallow copy. This is nothing but called example of shallow copy. Okay. This is the shallow copy diagram and example. I will show you in the program also. I will show you for that. Suppose I have a list L1 equal to suppose bracket start 10 comma 20, okay, 10 comma 20 comma 30 comma 40. Okay, 40 is the day. See, what is the L1 value, sir? L1 value is this one, 10, 20, 30, 40. So this is a nested list. Now what I'm doing, I'm copying the L1 value by shallow copy. I'm writing L2 equal to L1 dot copy copy. Now see, what is the L2 value right now? L2 value also same as it is. What is the L1 value? What is the L1 value? Here by writing this line, this is shallow copy. L2 value also same thing copied here, right? Now see, observe. I told what, sir? This L1 address and L2 address is different. Okay, L1 address and L2 address is different. See, this L1 address is what? This L1 address is 1007 and L2 address is what? 1008. Two are different address. But L1 of 0 address is the same. L1 of 1 address is the same for both L1 and L2. Observe here, I will show you that one. See, so L1 of 0 is this one, and L1 of 1 is this one. L2 of 0 is this one, and L2 of 1 is this one. Both the element address for L1 and L2 are same, but L1 address is different, L2 address is different. How to find, sir? ID of L1. ID of L1. Observe what is printed. Some 504 last 3 digits. Now suppose ID of L2. Okay, ID of L2. See, is it same? No, it is different. 904 address. It is a 904 address. Now ID of element, first element of L1. See, first element of L1. That means L1 of 0 is the first element of the L1. Observe what is the ID? 1136. Now ID of L2 of 0. First element of L2. Okay, address is the same. See, 1136, 1136. Here also address, here also address, same here. Because inner element address is the same in the shallow copy. In the shallow copy, new object is not created for inner list, but for outer list, the new object is created and different address location it is stored. But for inner list, it will not create the new address location. It will not create the new object. Same old address shared. Okay, same old address here shared. See, I have shown you here in the diagram also. This same 1005, this same 1005 is shared to here and also shared to this one. Okay, 1006 shared to this one, also shared to this one. Right, same. When I am doing the shallow copy, automatically the inner list, this is the inner list, this is the inner list, this address will be shared to the new list L2, right? It will not create, but the address of L1 is different and address of L2 is different. This one already here I have shown you the practical, right? So what will happen next? Observe what I am doing, sir. Now what is my L1 value? L1 equal to this one and L2 equal to this one. Now see, I will change the L1 first element value. I am writing here L1 of 0. Okay, L1 of 0, this is the first element, and this is the first nested list. In the first nested list, I will change the first value, which is 10 to 100. Okay, L1 of 0. Now see, L1 value is what? Now it is what? 120. It was actually 1020 earlier. Now it is changed by writing this line. I changed this 10 to 100. So if I am changing in the L1, is it reflecting in L2? Yes, 100% it will also reflect into L2. Observe here, L2 will also change here 10 to 100. Why? Because they are sharing same reference address. See, 101 and 105, both are shared here, right? Here also 101 and 105, both are shared here, right? So anything I'm changing in the list 1, that is reflecting in the list 2 also. Suppose what I'm doing here, I'm writing here, suppose L2 of 1, L2 of 1 means second element of list 2. Second element of list 2 is nothing but this one. Second element of list 2 is 30, 40, and inside the second element, two elements are there, 30 and 40. What I'm doing here, L1 of 0, I mean first element, I want to make it to 30 to 3. Okay, it was 30. Right now L2 of 0 is 30. Now I will make it 3. If I'll make it 3, is it reflecting in L1? L1 is 30, right? Is it reflecting? Is it changing in the L1 also? It become 3 or not? Observe here, L1 also. Sorry, what happened? Okay, I'm writing here L2 value right now. Observe, it is changed to 3. So here by writing this line, mistakenly these two values came here. So here by writing this line, now it was 30, now it is changed to 3. Now if it is changed in L2, I am changing in the L2, right? L2 of I have written. Is it reflecting to L1? Observe here, L1 also changed to 3. That means in the shallow copy, if any changes we are doing, then it is also reflecting to another list. Okay, another list, original list or duplicate list, where we are doing the changes, everywhere the changes are reflecting. And what is the important point here about the shallow copy? In the shallow copy, all the inner list object all the inner list object reference will be copied. Reference means address number will be copied, as well as elements address number also copied here. And any changes we are doing, that is also reflecting in the both list, right? Next one is deep copy. What is happening in the deep copy? Observe here, I will show you diagrammatically first. Suppose the list having, I have list L1 equal to same, suppose 10 comma 20 and 30 comma 40. Four elements are there. So this is the first element of L1, and this is the second element of L1, and this is the first element of L1 having two element. Okay, 10 and 20, indexing 0 and 1. Here indexing 0 and 1, and first element, this is indexing 0 and this is indexing 1, right? So if I'll draw this one, this is L1, L1, and L1, this is first element of L1, is contain two element again, 10 20, and here also two element again, and 30 40, right? Indexing 0, indexing 1, 0 1. This is called L1 of 0 list. This is L1 of 1 list. Okay. First element L1 of 0, second element L1 of 1. Now what will be happen, sir? Here same thing, for L1 object will be created. Object will be created. Okay. For L1 of 0, one object will be created. For L1 of 1, one object will be created. If I'll write like this, same thing will be happen. And for L1 of 0, first element one object, second element one object, third element one object, fourth element one object will be created. And everything having address number, suppose 1001, 1002, 3, 4, 5, 6, and 7. This is L1, L1 of 0, L1 of 1. This is for 10, this is for 20, this is for 30, and this is for 40. Right? This is for 40. Now see, if I'm writing like this, then internally like this memory will be allocated. So here 1005, 1006, and this is 1007 for L1, and here 1001, 1002, 1003, and 1004. Now I'm doing the deep copy. Suppose I'm doing the deep copy to L2. Here copy model is required, right? First I have to write import. I have to write import copy module. I have to import first, otherwise error will come, because the deep copy is done by the function named as a deep copy. So I have to write here copy dot deep copy is the function name, copy is the module name or library name, deep copy of L1. If I am writing like this, then what will be happen? This value totally copied to L2. This value will be totally copied to L2. It will become 10, 20, 30, 40. Totally copied to L1 by deep copy also. But internally what happens? The elements are copied, but internally what happens? Observe here. Very important. Internally what happens? For L2, okay, this is L2, right? This L2 equal to L2 become like this. For L2, new object will be created. New address location will be reserved. So new object will be created for L2. Okay. For a new object will be created. This is become L2. If it is 1007, then address will be changed. Another address, suppose 1008. Right? 1008. Suppose. Now this is the first element of L2. This is the second element of L2. For the first element of L2, that means L2 of 0. Okay, L2 of 0 is the first element, and L2 of 1 is the. For those two elements also, two new address location will be created. Two new address location will be created. One more this one more this one will be created. And here this address location number is 1009, suppose 1010. Okay. Then now the first element of L2 contain two element 10 and 20. Okay, 10 and 20. So what will be happen for this 10 and 20? New address location will be not created, rather the same address value of L1 will be shared. The same address value of L1 will be shared here. Observe here. So here this is for L2. This is for 1 minute. L2. The L2 address is this one, and here this is 1009 and 1010. It contains two element. It is also contains two elements. Okay. Here 1005, the L1 list first element, but here L2 list first element address is not same as L1 list first element. Here 1005, here 1009. New element will be reserved, new address will be reserved in the deep copy. In the shallow copy it is same. Here 1005, here also 1005. In the shallow copy both value are same here, but in the deep copy it is different. But what about these two elements? These four elements? In this 4 element, the exactly 1001 will be copied. 1001, 1002, 1003, 1004. Right? Difference is what? Difference is in this level only. Difference is in this level only. In the shallow copy, these two are different. L1 address also different, L2 address also different in the shallow copy. But in shallow copy, the first element of L1 address and second element of L1 address, first element of L2 address, second element of L2 address, all the address are same. Okay, first element of L1 address is same as first element of L2 address. Second element of L1 address is same as second element of L2 address in the shallow copy. But in the deep copy, it is changes. But all the individual element address is same in both shallow copy as well as deep copy. Sir, what is the problem? Problem is what here? What type of things we are going to get here? Okay, suppose I'm changing the L2 value 20. Okay, L2 value 20 to 200. Now tell me 200 is at which location? 200, 200, 200. Here is the 200, right? Sorry, 20, 20. 20 is in which location? 20 is in 1002 location. 1002 location means 1005, 1002 location. 1005, 1001 location. 1006, 1003 location. 1004, 1004 location. 4 location. Now here 20 is in this 20 is in 1005. Okay, 1005 and 1002 location. Okay, location L1 of 20 is in L1 of 1005 and 1002 location. But here I am changing the 20 to 200, right? So 20 to 200 as which location, sir? This location. 20 is in which location? 20 is in L2 of 1009, 1002 location. Okay, 1009, 1002, but whereas it is 1005, 1002 location. Is this two location are same? Not same. If I am changing here 200, 20 to 200, that means in this location 200 will be changed, but not here. Here it will not change. So 200 only changes here, but 200 will not reflect here. Is it as it is? 20 will be there, because this location number, this combination you observe 1009, 1002. This combination is not same as 1005, 1002 combinations, right? Because this is the first element, or first member of list 1 address. This is the address changed here in L2 first member. That's why this problem is happening. So what will be happen here? What will be happen, sir? Every individual element address location is same. 1001, 1002, 1003, 1004. Here also 1001, 1002, 1003, 1004. But the nested list element address is not same here. Here 1005 and here 1009. So that's why if I'm changing any element in the list 2, that will be not reflect in L1, list 1, or if I'm changing any element in the list 1, that also will not reflect in L2. But in shallow copy, everything will be changes, everything reflection will be there if I'm changing anywhere, right? This is the example of deep copy. This is the example of deep copy. Okay, I have to use module here. The module name is copy module. Without copy module, it will not work. This is the example of deep copy. Right, deep copy. See here, I'll show you the programmatic example here. Now, what is the L1 value, sir? L1 value is right now 120, 340. L1 value. Okay, I'm declaring once again L1 equal to suppose 10 comma 20. comma 30 comma 40. I declare the two values here, right? Now 11 value is this one. What is the 11 value? This one. Now I am doing the deep copy. For doing the deep copy, first I need to use the copy model. If I will not use the copy model, error will come. Observe here. Suppose I am doing L2 equal to copy dot deep copy in the bracket L1. See what happened? L2 equal to copy dot deep copy. Okay, at the top I have imported. That's why. Okay, I will show you. I will close this one. If we close this one, then sharing will be done, not done. Okay. Because here observe, I have written here. What I have written here. Here import copy. I have written here. That's why it is coming there. No error shown. But if I am not written import copy, then definitely error will come. Now see what is the L2 value. L2 value is the same. L1 value is 10, 20, 30, 40. L2 value also 10, 20, 30, 40. I told if I'll copy this one, what will be happen? The object of L1, address of L1 and address of L2 is different, right? Observe here, address of L1 and address of L2 is different. Now ID of L1, see what is printing 568. Now ID of L2 different or not? That is 9568. This is 8864. Now again what I told sir, in the deep copy what happened? In the deep copy this is different, right? This is also this is different, this is not same. And also this L1 of 01005, L1 of 11006 and L2 of 1, this is L2 of 1, this is L2 of 0 and L2 of 1. This address also not same. This is 1005, this is 1009. But in shallow copy, this is 1005, this is also 1005. This is 1006, this is also 1006. But in deep copy, in this level also, the address of this element, okay, this nested list is not same, it is different also. That's why the problem is coming when I'm changing anything. This is not reflecting in another list. Observe here, I'll show you ID of L1 of 0. L1 of 0. See what is printed? 9696. Similarly, ID of L2 of 0. In shallow copy, the two values are same. ID of L1 of 0 and ID of L2 of 0. Already I have shown you in the top. See, ID of this is shallow copy, right? ID of L1 of 0 is what? 23762 1136, and L2 of 0 also same address. This is shallow copy, right? But in the deep copy, what will be happen? This is the ID of L1 of 0, but see what is the ID of L2 of 0? Is it same or different? It is also different. 23 and 760. This is 696, right? It is different. So that's why if any changes I am doing, suppose I am writing here L1 of 0, okay, L1 of 0, L1 of 0 is nothing but this element. In this element, I want to change the first element. This is 0 index. Suppose L1 of 0 equal to 100 I am doing. Okay, see L1 changes 100, 10 to 100, but L2 it was also 10. Is it changes to 100? No, it will not change to 100. Observe L2, what is coming? 10 coming. It is not changed because the address here it is different. Address here is different, so address is not matching here. Address is not matching here. Here 105 102 combination and here 109 102 combination. This combination is not equal to this combination, so it is not reflecting. Only in one list it is reflecting. So this is the deep copy. So what is the important point here? You need to write here about this shallow copy and deep copy. Observe here, I will write some important point here. This is the concept. So this is the shallow copy. and this is deep copy. What are the several points deep copy? But the first point, sir, first point is here using of module copy module is optional. You may use, you may not use, no problem. But here compulsory copy module has to import. Import means we have to use, otherwise error. What is the second point, sir? Second point in the shallow copy. Here every elements, okay, every elements address will be copied. Every element address will be copied, right? Every element address will be copied. But here, what will be happen? Okay, only inner list element address will be copied. Okay, copied. Here every element address means outer list elements address and inner list element address, both address also copied. But here only inner list element address will be copied, but outer list address element will be not copied. It will create a new address location for the outer list, right? That's why what is the next point, sir? Next point is any changes done to any list, okay, to uh, any changes done to either list, okay, either list, that will be reflect in both, okay. But here in third point, what will write? Any changes done in either list, any changes done to either list, that will not reflect, that will not be reflect in both, okay, that will not reflect in both. So this is the three important point I have written here for the shallow copy and deep copy, right? This concept is little bit confusing actually. Through the example, programmatic example, it can be easy. So you just try to mm, look at these examples. Example, programmatic example, what I have given. So in that you can address location number for what it is, for which element it is changing, for which element it is not changing, right? So this is the about the shallow copy and deep copy, copy of one list. You know, copy also possible by assignment operator also. Assignment operator. Okay, I'll write here copy of one list. Copy of one list also possible by assignment operator. Assignment operator. Okay, assignment operators. So that means suppose I will write here. Observe here. Suppose I will write here L1 equal to, suppose L1 equal to what, 10 comma 20 comma 30, okay, 10 comma 20 suppose, comma 30 comma 40. right? Like this I have written. Now I'm writing L2 equal to L1. That means the value of L1 will be copied to L2. Now see, L2 is how much? Same value or not? 10, 20, 30, 40. This is also possible. But a difference is there in the shallow copy, deep copy, and assignment operator. By using the assignment operator, difference is there. What is the difference here? Observe here. Difference is very simple. So if I'm writing here L1 equal to 10, 20, 30, 40, right? And here what will be happening internally for L1 object will be created, and it is having two elements. First element having two elements, second element also having two elements. This is L1 of 0, sorry, okay, this is L1 of 0, this is L1 of 1, right? Then what is happening internally, sir? I told for L1 object will be created. Okay. For L1 object will be created. For L1 of 0 object will be created. For L1 of 1 object will be created. And for every member 10, 20, 30, 4 object will be created. Just previously I told like this diagram also. Same thing, object will be created. Suppose this is value is address number is 1001, 1002, 3, 4, this is 5, this is 6, and this is suppose 7. This is L1, L1 of 0, L1 of 1. This is for 10, 20, 30, and 40. Here 1001, 1002, here 1003, 1004, here 1005 and 1006 and 100 for L1, right? Like this in the last two example also I have shown you. Now I am writing, sir, what? L2 equal to L1. Okay, L2 equal to L1. That means what will happen? It will become same 10, 20, 30, 40, right? That means 30, 40. So for L2, the value is come here, L2, L2, and for here also two element, and here also two element. Okay, so what will be happen? Same 1007 address will be copied to L2. Here, no extra object will be created for L2. Okay, no extra object will be created for L2. For it is not created for L2. No extra object. What will be happen? Rather, it will be not created. Rather, the same L2 L1 address will be copied to L2, and L1 of 0 address 1005 will go to this one 1005. 1006 is go to this one, right? 1001 will be come to here, 1002, 1003, 1004. Okay. Now if you'll compare these three copies, then what is happening in the assignment operator copy? By using assignment operator copy, everything, outer list address, inner list address, and every element address, all are same. All are same for L1 and L2. Okay, now mark my word. If I'm doing copy by using assignment operator, then outer list address, this is the outer list address, 1020 address is 1005, and 3040 address is 1006. Both 1005, 1006 is same for L1 and same for L2. And L1 having address is what? 1007. So same 1007 will be copied will for L1, and it is also copied to L2 also. But and the element for 10, 20, 30, all 1001, 1002, everything will be copied to L2 also. But in shallow copy, what will be happen? For this outer list L1, there will be one more address location created. L1, one more address location is created, right? For L2, L2 one more address location is created, and these two addresses are same for L1 and L2. Whereas in the deep copy, for this level and this level, new address location will be created, and these values are same. Okay, these values are same. So here three levels, this is first level, this is second level, and this is third level, right? So all the levels address are same for assignment operator copy. These two address level same for shallow copy, and only this last level address is same for deep copy. These two are different, right? So this is the difference between shallow copy, deep copy, and assignment operator. Here observe, I will show you ID of L1. What is the ID of L1? 2376274576. ID of L2. See, ID of L2 is what? Same or not? It is same. But whereas, observe, whereas in shallow copy, ID of, not this one. 1 minute. Here, see, L1, ID of L1. What is the ID, sir? 504. And what is the ID of L2? Here I have done the copy by shallow copy. This is what is the ID of L2? This one is the ID of L2. This is different, right? It is different, but in equal to operator it is same. And here first element address L1 of 0 is this one, and L2 of 0. These are same. These are same, right? Here also, if I write here ID of L1 of 0, see, and ID of L2 of 0, both are same. 208 90 right? And here element also same. Any changes I will do, that will be reflected everywhere, right? Everywhere it will be reflected. Suppose I am writing here L1 of 0. What is the element set? 10. Now I'm making to 100. Now see, L1 is changed, L2 also changed or not? L2 also changed, right? In assignment operator copy, in the three level, okay, outer level, inner level, and element level, every address is same. In shallow copy, outer level address is different, inner level element address are same. In deep copy, outer level address is different, inner list address is different, only element address is same. So by doing this, what is the difference between the difference? Already I mentioned the difference between shallow copy and deep copy. So this is little bit, I mean, confusing, this concept actually. So through this example, you try to understand, then it become easy, and practice it at least 1 to 2 times. So I hope this will be very much helpful to you. So I conclude here. In the next video, I will discuss some new important topic on the list. List is not completed, still it will take 2 to 3 class more, right? So I conclude here. Take care and bye.